Welcome back to Learn Math by Example. Today, let's work on an application problem combining both arithmetic sequence and series. Here's our problem. A small business starts its first year with a profit of 25K. Due to strategic investments, their profit increases by $4,500 each subsequent year. First, in part A, we have to find what will be its profit in their 8th year of operation. This is a typical arithmetic sequence problem since we have a constant increase per year and it's asking for the profit in a specific year, which means we are looking for a term in the arithmetic sequence. Now we can identify our first term as $25,000 and the annual increase is $4,500, which is our common difference. And we want the profit in the 8th year, so n is equal to 8. Using the formula from the formula booklet, un is equal to u1 plus n minus 1 times d, we can get, by replacing our values into the formula, u8 is equal to 25,000 plus 8 minus 1 times 4,500. This simplifies to 25,000 plus 7 times 4,500, which is $56,500. So their profit in their 8th year will be $56,500. In part B, they are asking about the total profit over the first 10 years of operation. This time, we need the total profit, indicating that we are looking for an arithmetic series. Again, U1 is still 25,000 and D is still $4,500. We're interested in the total profit over the first 10 years, so N is 10. From the formula booklet, we know that Sn is equal to n over 2 into 2u1 plus n minus 1 times d. Now, replacing our values into this formula, we get S10 is equal to 10 over 2 into 2 times 25,000 plus 10 minus 1 times $4,500. Simplifying this, we get S10 is equal to 5 times 90,500. Therefore, their total profit over the first 10 years will be $452,500. Now, this problem beautifully illustrates how arithmetic sequences help us find a specific value while arithmetic series allow us to calculate accumulated totals, both crucial concepts in IB exams. Following our first application, we'll be working on a practical problem that highlights how mathematical models help us understand real-world phenomena, even when they are not perfectly textbook examples. Such models can be used as a topic for your IA. Let's dive into our example. Imagine a new mobile game tracking its daily active users, or DAU, for the first 5 days. Here is the data. On day 1, we have 150 users. On day 2, 175 users. On day 3, 200 users. On day 4, 220 users. And on day 5, 235 users. First, we need to determine if this daily user growth perfectly follows an arithmetic sequence and justify our answers. Remember, an arithmetic sequence has a constant common difference between consecutive terms. So by calculating the differences between day 1 and day 2 and day 3, etc., we get the following. From day 1 to day 2, the increase is 175 minus 150, which is 25. Day 2 to day 3, it's also 25. But from day 3 to day 4, the increase now becomes 20. And from day 4 to day 5, the increase is 15. Since the differences are not constant, we have 25, 25, 20, and 15. The daily user growth does not perfectly follow an arithmetic sequence. Moving to part B, we were asked to assume that the growth was approximately linear for the first 3 days. Based on these days, we'll calculate a common difference and suggest a simple arithmetic model for the number of users, un, on day n. For the first 3 days, the common difference was consistently 25. So we'll use d equal 25. The general formula is un equal to u1 plus n minus 1 times d. Replacing u1, which is 150, and d equal to 25 into the model, we get un is equal 150 plus n minus 1 times 25. Now we can predict the number of users on day 7 using this model from part B. So using our derived formula, we get un is equal to 150 plus n minus 1 times 25. For day 7, we set n equal to 7. So u7 is equal 150 plus 7 minus 1 times 25. This simplifies to u7 equal to 150 plus 6 times 25, which gives us 300 users on day 7. Finally, it asks us to discuss 2 real-world factors that could cause the actual user growth to deviate significantly from our prediction over a longer period. First, consider marketing and virality. Initial growth might stem from targeted advertising or attracting early adopters. However, sustained, perfectly linear growth is rare. Actual growth depends on factors like viral spread, being featured in app stores, or continued changing marketing campaigns, none of which provide a constant user increment. Second, let's think about user retention and churn. Our simple linear model assumes that every new user stays. In reality, some users will stop playing the game, a phenomenon known as churn. This net loss of users can significantly reduce the overall growth rate. Factors like game updates, encountering bugs, or new competing games can all influence how many users stick around. This example demonstrates that while simple mathematical models are powerful tools for initial analysis and prediction, real-world complexity often requires us to interpret results critically and consider external factors. Keep practicing these analytical skills for your IB exams. And here we come to the end of our lesson. To get more practice and solidify your understanding, you can visit us at samshub.com. There, you will find free lessons with lots of exercises. If you know anyone who would need help in his homework or support in writing his IA, you can also direct him to our website. The link is in the description below. Don't forget, discussion is a crucial part of learning. So if you have any questions or comments about this lesson, feel free to leave them below or on the website. Join us for our next lesson where we'll explore a geometric sequence. Thank you for watching and see you in the next lesson.